We will start this prayer with We'll start this program with prayer by Dr. S. Ruby, Department of Physics. Let us bow down our heads for prayer. Heavenly Father, thank you for this wonderful day. As we have gathered here for this special occasion, let your grace be sufficient for us. Lord, we come to you asking for your guidance, wisdom, and support as we begin this meeting. Help us to engage in meaningful discussions, allow us to grow closer as a group, and nurture the bonds of college community. We pray for our principal, all the teaching and non-teaching staffs. We pray for our students. Lord, help them to grow in knowledge and glorify you. Be with us throughout this day and bless each one of us. In Jesus' name I pray. Amen. Thank you, ma'am. I deem it a pleasure to welcome you all for the third day of Vigyan Sarvatra Pujyate, Festival of Scope for All. I take this opportunity as my privilege in welcoming Dr. M. Davamani Christoba, Principal and Secretary, for being backbone of our institution. I am elated to welcome Dr. Ebenezer Chellasamy, Head Kodaikanal Observatory, Indian Institute of Astrophysics, Kodaikanal, who is going to deliver a talk in this auspicious event. I welcome our dear HODs, Department of Physics. I welcome Dr. S. Paul Mary Deborah, Head UG Self-Finance Physics, who is being moderator for this event. I welcome Dr. G.C. Abraham, the Vice Principal, Dr. C. Dorothy Salsia Bursar Ma'am, Dr. K. John Chellasamy, Coordinator, and Dr. S. Priyadarshini, Deputy Coordinator. I extend my warm welcome to all our faculty members and dear students. Now honoring the chief guest by John Chellasamy, sir. Thank you, sir. Dr. Paul Mary Deborah will take over the session.
Good morning to all. It's my great pleasure to introduce today's speaker, Dr. Ebenezer Chellasamy. Ebenezer is the student of 1988 batch of our postgraduate physics department of our college. He did his bachelor's degree in physics at Americancollege, which is affiliated to Madurai Kamaraj University at the time. Soon after MSc in Americancollege, he joined Raman Research Institute in a project, IAA Joint Astronomy Project, which is based on Gauri Bindanur Radio Astronomy Center. He was a student of Instrumentation Department at Indian Institute of Science, Bangalore in 1997. Later, he returned to astrophysics to build instruments for radio astronomy group at IAE. Ebenezer received his PhD from the University of Mangalore in 2010. He served as a scientist at Indian Institute of Astrophysics, Bangalore, and held visiting position at the National Institute for Space Research, Brazil, for 3 years. For the past 3 years, he is working as a head of Kodaikanal Solar Observatory. He is a member of Board of Graduate Studies at Karunya University, Coimbatore. He has more than 21 years of research experience and has published more than 18 research papers in national and international journals. He has taught courses on solar radio astronomy and instrumentation at undergraduate and postgraduate level in international summer schools, and in most of the universities he is taking more number of courses. He guided nearly 7 postgraduate students for their project in solar radio astronomy. His major research interests have been in the area of solar radio astronomy, instrumentation, and astrophysical plasma. With this brief introduction, I am inviting Dr. Ebenezer to deliver his talk. The session is yours, and so you can start.
Okay. Good morning, everyone. It's really a mixed feeling of coming back to American College because every corner I roam around. I also stayed in Dudley Hall. How many of you from American College itself? Can you please lift up your hands or just raise your hands? Students from college, American College? All of them. Then why you are struggling? I'm asking a question, who are all from American College, then you should lift up your hands, okay. And I studied in the PG Physics department, and we used to extensively use everyone used to use the library. I use only workshop. Most of the time I spent in workshop. We had a freedom of working here. It's a very nice to see the young students here. And today we are going to study from the, I'm very happy for the invitation being extended by the principal and the head of the department and teachers and professors here. I'm very happy to be with you all. And today is the 75th milestone from the world of Indian science and technology. I divided my talk into 2 parts. One, I just wanted to show you. Yesterday nights I just saw that I need to remember how old people or old Indian astronomers or Indian mathematicians they worked. And later I thought I should take you virtually to Kodaikanal. How many of you would like to come with me to Kodaikanal? Okay. I just wanted to show you around virtually I will take you around, though then I physically also I welcome you to visit Kodaikanal Observatory. It's one of the oldest institution, more than 120 years of observations or research is there. And it's a huge campus, 140 acres, and it's very cool, naturally air conditioned, so you will love the place. Okay, we'll go back here, and I would like to start with Aryabhatta. Most of you might have heard Aryabhatta during your school days itself. Aryabhatta was a great mathematician, and you can see that one in Sanskrit. Aryabhatta was an Indian mathematician and astronomer, and in the classical age of Indian mathematics and astronomy, he flourished in the Gupta era and produced works such as Aryabhatta and mentions the Kali Yuga. And he was only 23 years old. I think most of you are less than that age, am I right? So he got intuition and he got really many ideas to work on that one, Aryabhatta. And to honor him, Aryabhatta later he communicator of the Brahmagupta and mathematics and Kala Kriya, the calculation of that time. Kala means time, and Kriya means it's equation or thing, Kala Kriya, calculations of the time, and Gola means it is a globe. And he was doing some kind of the spherical astronomy. Being the science, I just wanted to tell you a little bit about physics, not even physics. Physics is the ocean, where Professor KG can tell that one. Starting from the nuclear physics, everywhere it is there. I just wanted to pick up little bit from astronomy and a little bit from the mathematics. That's what I am to do the justice. And he did some work with spherical astronomy. And you can see this picture in Ayuka. And this picture I have taken from the Ayuka. To honor him, the government of India, when they sent a first satellite, they named Aryabhatta. So it's really a prestigious thing to study or think about Aryabhatta. And later him, the Brahmagupta came. The Brahmagupta, he was also a greatest Indian mathematician. India produced a lot of mathematicians, and along with astronomy. So they always used to see the planets, comets, and all the things. They used to do the computations and all the stuff. And Brahmagupta, he did something, and he was the first to give the rules to compute zero. He did great mystery for all students, am I right? We all got, sometimes we get teachers put a zero. This man responsible for that. Okay. So he is our enemy. Okay. Brahmagupta gave the rules for computing, because you just give something, you just take out back everything. And people didn't know till he came forward to give that particular note, Brahmagupta. And Bhaskaracharya is also a very famous person, and he did lot of mathematics and astronomy. And you might have know about the pi. Pi is how many degrees? Any student from here? Oh, everybody is telling. Everybody is intelligent. I thought only one will be telling the answer. I can give some gift to them. But everybody is an intelligent people here. I don't have anything to give you. Let me ask some more tough questions so that I can give you something. Okay, that sin x equal to 16x, this equation, it was designed by Aryabhatta. Later days, you can see that one, you can more or less, the deviation is only 1.9%. You just imagine, those days people never know what is pi, what is the volume, or what is the area of the sphere or circle. Those days he did a lot of calculation and he derived this number, which is more or less matching with our own present day with the supercomputer and other things. You can do this calculation. And Bhaskaracharya, Acharya means teacher. In Sanskrit means teacher. Ruby is Acharya. Okay, Ruby teacher. Okay, like in that one, the Bhaskaracharya, to avoid the confusion, they call the Bhaskaracharya 1. He was also an Indian mathematician. Bhaskara, the next Indian satellite they launched, they named his Bhaskara. And next to our neighbor in Kerala, this Madhava Nambudiri, all the time they were thinking about lot of calculations. Calculation in the sense series, where the world was not at all know about how the series of numbers will be there. And he was all the time people were concentrating on pi. Pi was more like an attraction. There was one Brazilian, one author, he wrote a book about a pi. And he starts with Pondicherry. The story starts from Pondicherry. And it's very interesting, like when people originated or older people, they want to tell something about mathematics, always their points will be, they point towards India. This great mathematicians, he lived in the year 1340 to 1425. And he was doing some infinite series and he did some calculations. And to some extent, it was really true. He considered to be the founder of Kerala School of Astronomy and Mathematics. One of the greatest mathematicians and astronomers of the Middle Ages. Madhava made a pioneering contribution in the study of infinite series. That already we know that. In physics, we will all study in mathematical physics. And he also did some calculations, calculus, trigonometry, geometry, and algebra, all the stuff he has done. And I cannot, the entire stuff, in the entire talk, I cannot miss out one person. He is nothing but Srinivasa Ramanujam. And I was giving a lecture in the SRM University. Prior to me, there was one lecturer, he was talking about, for almost 1 hour, he was talking about Srinivasa Ramanujam. Whole series. And he gave me one book also, Anandathai Arindavan, meaning the man who knows the infinity. Very interesting talk. And see, the struggle he had is, he didn't have a paper to do all the equations. So he used to write everything in a slate. Then finally, the starting point, he will know that one, and the end point he know. Then he will erase and he will write in the paper. Still, people are in the mathematical sciences, people are struggling to solve what are the things he has imagined or he was dreaming about. He joined or he worked for the shipping corporation or the port, to only to grab the packaging papers. So he was so longing for a paper. I don't know, like if I know that one, he is need of paper, I would have given tons of paper. Even in the paper mill, we would have donated to him. Such an intelligent person, he was lacking for something, and he derived many intelligent equation. In Tamil, they call Anandatte Arindavan. And the book irukku. Just if you can get from our library, please go through that one. It's a very, very inspiring book for you all. And this is about the mathematics analysis. You say anything, number theory, infinite series, on continued fractions, many things he solved. Very interestingly, Srinivasa Ramanuja. And there is another book, The Last Notebook. Many things people are trying even still to solve his problems, and it's really a very interesting topic. And Varahamitra is in Indian tradition. He believe him. He is one of the 9 jewels, Navaratnas, in the court of Yashodaman in the Malwa. And this man is also, they were doing about the planetary movements and the planetary studies about the rainfall, cloud formation, agriculture, mathematics, gemology, and he did many topics. And he was one of the, if anyone to consult him, they will go to him, it seems. He was so brainy person. And let me come, all these people I do not know, even including the first director of our Indian Institute of Astrophysics at Kodaikanal. And the British regime stopped and he took over, and he is from meteorology. He was a director of the Kodaikanal Observatory, responsible for installing the Kodaikanal Tunnel Telescope. One of the beautiful and one of the tunnel kind of the stuff I will be telling in my next presentation. I will tell you while taking through the journey of Kodaikanal Observatory. And Saha, many of you are sitting, the professors, they cannot ignore Professor Meghnad Saha. And he made the first equation for ionization. And everybody knows that one. That is the internal state of how the nuclear reactions are happening or ionization is happening in the internal structures of the sun or even the different stars. Saha first derived that ionization equation. And we need to be very proud of him in our modern era. He did a very intuitive calculations and he derived many equations. And Professor G. Srinivasan, most of you may be knowing. And he is also alumnus of our Americancollege. And he moved to Raman Research Institute. We gave him 1 hour time to talk about Subramanian Chandrasekhar. He exceeded 1.5 hours. Even he didn't stop at all. He started doing many things from Subramanian Chandrasekhar. He visited our Kodaikanal Observatory very interestingly. And I just skip it. And most of you may be knowing about the Chandrasekhar limit. Have you heard about Chandrasekhar limit? Only bus board we are seeing about a speed limit. Along with the speed limit we have for the stars, and Chandrasekhar put a limit. It was thoroughly argued by many people, including Sir Arthur Eddington. Nobody could understand what he is trying to tell. And his students, they got PhDs, and their students, they got even Nobel Prize also. He was denied, and very later, the world recognized and gave him the Nobel Prize. Shall we give a big hand clap? He is a Tamilian, and he is an Indian, and he moved from our own India, and he moved to University of Chicago. He was a professor for a very long time. Very standard journal in astronomy is Journal of the Astrophysical Journal. Publishing in that one is too difficult. And Professor Chandrasekhar, he was an editor for the journal for very longer time, along with the Nobel Prize. William Fowler, theoretical studies on the physical process or the importance of the structure and evolution of the stars, he shared the Nobel Prize. And I had a chance to meet him one-to-one. It's really a great privilege to meet such a noble laureate and very humble person. Every 10 years, he used to change his research field. And every 10 years, people will be working on all the old of his problems. Starting from statistical mechanics and stellar dynamics and many topics, he is a very brilliant person, Subramanian Chandrasekhar. And let me move on to Chandrasekhar limit is depending upon the mass of any early type of the star. If the star's mass need to be 1.4 solar mass, so that it will end up as a white dwarf. and for his noble discovery, he got the Nobel Prize. Let me move on to tell something few about Vainu Babu. I have not seen Professor Vainu Babu, but Vainu Babu, he was an instrument to build or make the Indian Institute of Astrophysics. And he was working for a meteorological department. He went to Harvard University. Harvard University, he saw many things, and he implemented most of the things in Kodaikanal. And he is also very famous for his discoveries. 1954, he discovered there is the calcium K line. I don't know how many of you know about spectroscopy. The word spectroscopy, if you fold your hands like that and slowly you will dip into sleep. I don't want people snoring here, okay? Good. If you can ask him some questions, you are very well, you can ask the questions, you can raise your hands and you can ask questions. Bapu, he was studying about the calcium K. The wavelength corresponding to that calcium K is 3933.4. And he discovered the different latitude of the sun, the calcium K profile is changing. Am I talking something in Greek and Latin to you? Latitude of the sun. See, latitude means the equator is 0 plus 90 to minus 90. He saw that profile of the width of the calcium K line is changing. And he suddenly turned his telescope towards other stars, and he found that many stars are having many different profiles. Very interestingly. And in 1954, Professor Bapu, he published that result. And that made him as a very great person, because people were working on the stellar astronomy. They were all stunned by his discovery. And he rose up to the level of international president of International Astronomical Union. So Professor Bapu, he contributed most of the things he contributed from our own Kodaikanal, Tamil Nadu. We should be proud of him. And Bapu also found a comet. Very interesting. I have a lot of pictures about the comets. Very interesting. When I was a student here in the year 1986, most of you are not born at that time, and in 1986, we studied about a comet Halley here. We used to watch Halley's comet in the sky. Very interesting. And Bob Newkirk comet, that is 1949 N1, he received the comet medal, Donoghue medal, from the Astronomical Society of the Pacific, and that is the only person in the whole India. What is the population of India? Some number. Why so sudden? When I ask for a public thing, why so sudden silence? What is the population of India? Tell me. என்னப்பா இந்தியன் பாப்புலேஷன் சொல்ல மாட்டேங்கிறே, பிசிக்ஸ் டாக் பேசிட்டு இருக்கும்போது 140 crores. Okay, I just looked into you. This is a small gift for you. Okay, you didn't tell, therefore I am giving you. Interesting. Okay, that Bapu, 140 crores of people are there, but no one has named after, so far, nobody ever found any comet in Indian name. Bapu named that. Bapu, he is from Kerala, and he went to Hyderabad to study his masters in the Americancollege. Then he moved to Harvard to do his PhD. When he returned back, he was a very influential person. And Bapu, he also, with Newkirk, he made us some models on the outer atmosphere of the sun that we call solar corona. And Bapu is a very interesting personality, and you should not forget about Narlikar. And including Stephen Inbanathan, they are very, and maybe sir also, KG sir also, they are all one-to-one corresponding with Narlikar. Narlikar, he is a man who popularized astronomy in the entire country. He is from Maharashtra, and he is a great theoretician, and he is known for highly Narlikar theory. The synthesis Albert Einstein theory of relativity and Mach's principle he proposes to the internal mass of a particle is a function of a mass of all over the particle multiplied by the coupling of constant. And he is a theoretician basically, but he has a passion for students. He is so interested to educate students, and he formed the IUCA, Inter-University Center for Astronomy and Astrophysics, and it liberally helped his university teachers. He will give the to and fro for them and give the great hospitality, lot of literature. Am I right? And we should be very thankful to Narlikar. And Narlikar is one of the very famous person. And I should always mention about Kulkarni. Kulkarni is a very friendly person. When he came to the talk or presentation, we were all sitting in the audience and we were all, he's a very, very famous person. He was very humble. He was coming with the shorts. I was literally wondered to see him. First time I am seeing him, trouser போட்டு வந்தார் lecture கொடுக்க. தமிழ்ல பேசினா தான் உங்களுக்கு அதனோட இருமையே புரியும்னு நினைக்கிறேன். The shorts and all the things you won't understand. Okay, very interestingly, he was a very intellectual and very influential person in the entire Princeton University, entire United States. And to be very, in the software industry, everybody knows about Infosys, am I right? Infosys chairman, who is that? Narayan Murthy. Oh, super. I will give you what, don't forget. Okay, Narayan, immediately, that's what I want, that spark. You are so responsive to the talk. Okay, Narayan Murthy's wife? Wonderful, Sudhamurthy. He is Sudhamurthy's own brother. Okay, we are a little bit closer. So he did, and his advisor called Helios, and he purchased, he reviewed so much of articles, and to the surprise, everybody knows that one, he started his research in the field of pulsar. Pulsar, you all know about what is a pulsar. It is not a Bajaj bike. Okay, pulsar is a rotating neutron star, very interestingly. And the mass, I will tell you that one, you cannot take the scoop of neutron star or a spoon வச்சு எடுக்க முடியாது ஒரு neutron star because mass is so massive. You just put all the people in the campus in one pan, ஒரு தராசுல ஒரு panல வச்சுட்டு neutron starல இருக்க ஒரு scoop வச்சீங்கன்னா neutron star will pull you down. You put all the people in Madurai, you put on the one pan, it will pull you down. You put all the people, ADMK people, number is less. Okay, you put on the one pan, everybody will pull down. You put ADMK with DMK and all PMK, all people, all Tamil Nadu people. Oh, BJP, oh. You put all the people inside Tamil Nadu, it pull you down. Only one scoop of thing. You put all the people in India, that will still pull you down. You put our neighbor, that many people are there, our China, you put all the people, India and China together in one pan and another pan, you put only one scoop of neutron star, still neutron star will pull you down. All people in the whole world, including China, Russia, Ukraine, all people in the world, if I tell the number, 10 power 24 kilogram and all, kg won't understand. Kg means a kilogram. Don't, nobody will understand it. So you just imagine so much of neutron star mass, Kulkarni started studying it. It is almost 8,424 light years far away from you. I am telling you about a crab pulsar. Are you with me? If you put 1 second, the light will go and touch the moon. It may take a very many long years for you to travel by your aircraft or something. You put to touch that Pluto, the end of the solar system, it touches only 500 minutes, that's all. It's not that even far away. I'm not, he know that one, we are a Tamilian. He all the time used to talk in Tamil only. He will never talk in any other language. Such a nice personality. World highest observatory till date, because there is no other mountain more than Mount Everest. So you put anything in Mount Everest, it is the highest. So Indian Institute of Astrophysics, we have decided to put a telescope there, but temperature will be freezing cold. Because it's a cold desert, the temperature in the winter goes to minus 65 degrees. You cannot tolerate, you cannot imagine. Therefore, we have put a remote so that we can open the dome or close the dome or point the telescope to any direction sitting at the Bangalore, like with the remote kind of the stuff. And we have also put on a Hagar telescope, high energy gamma ray telescope at Mount Himalayas. And Indian Institute of Astrophysics, we launched the first Indian astronomical satellite that we called it as AstroSat. Can you please tell me? AstroSat. And there is a very important instrument is called UVIT, ultraviolet imaging telescope. That telescope is also can be seen here. It has a many other suite of instrument along with the TAFR
and the Raman Research Institute from Physical Research Laboratory, we have built that one. And in future, we are going to build a 30-meter class telescope. You just imagine, yes, a few days back, 2 days back, Professor, they did 500 crores for this big project. It is a huge mega project. Professor Asthana, he visited and he was applauded about our work. And in future, it will be 12 times sharper than the Hubble Space Telescope. How many of you heard about Hubble Space Telescope? Only very few. Girls? Okay, good to see that one. Edwin Hubble is a man who revolutionized our idea of our entire space. And Hubble constant is still, those who are studying about astronomy, they know about Hubble constant. It's still the expansion rate of the entire universe can be calculated. And Hubble Space Telescope, to honor him, government of United States, they called Hubble Space Telescope. That revolutionized our idea. Now, this images what we are going to get, it will be 12 times sharper. It's a huge telescope, almost 655 square meter size. It has 30-meter class telescope, and it has the 492 mirror segments. It's more like a honeycomb structures. Everything we are making in India, like polishing all the stuff we are making. It's a mega project, and many people are involved. It is almost 15 years we are working on that one. We will be sending all the things to Hawaii Island. There they will be assembling. Now you can see a human or some truck will be, I not put a truck here, then you can see that one, it will be very nearby. This is the way you can see the Milky Way galaxy from Kodaikanal Observatory. This is the real picture I have taken, okay? So I think I will stop here to take you to Kodaikanal, okay? It will be very interesting, just 4 hours from here, okay. I will welcome you to Kodaikanal Solar Observatory. I am just quickly I am going to take you, put your seat belt. I am not going to going very slow as I am going now, and sit properly so that you will be, I'll be going in a jet speed, okay? I won't go very slow. And we have, I am going to tell about the brief overview of our observatory. Then I'll be telling about the instruments, what we have past and present and future, what we are going to do. Quickly, I'll be telling about small results or discoveries what we made from Kodaikanal. And Indian Institute of Astrophysics, we have 5 branches. One is solar system studies. We do that one. I belong to the solar system studies. And stellar astronomy, already told you about Kavalur Observatory and Vainabab Observatory at Kavalur, and the Hanley Telescope, Himalayan Chandra Telescope. And theoretical people, they need only paper and pencil. They will sit and do all kind of the calculations, and they will be doing very intelligent job. And Indians are very good in mathematics, and they do a lot of computations also. And instrumentation, we build a lot of instruments. Even after going from American College, I started building the instruments only. Then space astronomy, it's newly emerging. Most of you may be very interested to join the space astronomy group. Like they will be doing all the space-related research they are doing. And we have located at various places, Kodaikanal, Kavalur, Gauribidanur, Hanley, Crest Hoskote, and AstroSat is our space mission. And the future space mission, we are going to launch another space station that is called Aditya. Aditya means it is not a comedy channel. Okay, Aditya means sun, that is Aditya L1. We are going to launch that one very shortly, we are going to launch. Okay, I already told about Vainabapu. You can see our Kodaikanal Observatory is 2.34 meter telescope is there in Kavalur, and 62 centimeter mirror we have at Kodaikanal. This is used to study about the spectral features of the sun. If I tell in your own language, like a 2 arc minute, 3 arc minute in astronomical resolution, you won't understand it. Do you understand arc second resolution? I think possibly not. And the visibility you also may not understand. Let me tell in your own words. And the visibility now, if you are seeing it, you can see only for 3 kilometers or 4 kilometers, not beyond that. Okay? When, if the visibility is very good, what is the resolution? Can anybody, physics students, somebody can tell what is the definition for resolution? What is the resolution? You all studied optics, am I right? we are looking staringly at me. எனக்கு ரொம்ப பயமா இருக்கு. நீங்க பார்க்குற பார்வையை பார்த்தா. சொல்லுங்க. Please tell me. What is the resolution? What is the resolution limit of a telescope? The ability to distinguish. Yeah. Correct. The nearby answer. Thank you. Okay. Good student. I think they should come up. Okay. Only boldness is more important. I think when you are a student level, people won't talk. They will talk with their friends. When they come to the meeting, they will think somebody what others will think. Let them think whatever they like. That is not our problem. Okay, fine. I think you should be bold. The students of American College, you should be really strong and you should be very bold. And this telescope, if the seeing is very good, if your visibility is very longer distance, and keeping 1 rupee coin in Meenakshi temple, Madurai Meenakshi temple, seeing from Kodaikanal, you can distinguish whether it's a 5 rupee or 1 rupee. If I tell in your language, I think you won't understand arc second, arc minute and all. Okay, that is, we can see in the sun atmosphere approximately 4 kilometer resolution, 4 to 5 kilometer resolution, depending upon the seeing conditions, we can measure it. This telescope is, oh, sorry. எங்கேயோ போகுது கொடைக்கானல் அப்சர்வேட்டரி. It's over. Open the other one. This one. Yes. This one. Down. Here. Okay. This is the location. There is a rose garden. It's a very nice place also to see Kodaikanal. Then, what? Okay. Just 3 kilometers away from that one, you remember 1786, you remember, this is our observatory. We are very close to the wildlife also. You can see a big bison, Deborah madam can tell that one. This is a fully grown up bison, almost 2 tons. You just imagine 2 tons coming with a velocity of 50 kilometers, coming and hitting and giving a momentum transfer. Don't be afraid, okay? And we are very closer, and we have a very old buildings, like 100+ years old buildings we have. And right hand side you are seeing that one telescope, that is we call the 6-inch telescope. And regular observation, they completed the construction of this the telescope structures and everything. They started in the year 1895. They completed in the 1890. From the year 1902, we have a regular observation happening from this telescope. And Norman Robert Pogson, he was the director of this place. Like me, he was 30 years long ago. And he was using this 8-inch telescope, what you are seeing here on the left-hand side. And still it is in a good working condition. And he used this telescope to study about the entire Milky Way galaxy. And he could be able to classify the stars. And this is the picture you are seeing. This book is there in our library. Almost 60,000 stars he could classify that one. I believe that is the first ever catalog made in the entire Asia Pacific region. Okay, this is a it is a pride of our Kodaikanal Observatory. You can visit our website, Indian Institute of Astrophysics, and we have telescope making, all the things we can make, like our American College mechanical workshop. We have a good workshop we have, and we have all the tools, everything we have for telescope making. And we are located at the highest peak of entire Kodaikanal Palani Hills. So this is the peak of the entire stuff. And we have the measurements like wind velocity, and we can measure about the wind speed, and we can also wind direction, and humidity, relative humidity, all water vapor related stuff, all meteorological related stuff. Also we are doing the measurements here. And he is John Evershed. In the year 1909, he discovered in the sunspot, I will take you to the sunspot. He is John Evershed. This is a sunspot. You can see 2 components there. One is umbra and another one is a penumbra. Umbra means dark in Latin. In the outer region of the penumbra, he discovered there is a radial flow of gases. Are you with me? There is a radial flow of gases in the penumbra of the sunspot. He discovered being there at Kodaikanal. And to honor him, after 100 years, Government of India, they published a postal stamp for him. and he is John Evershed, and along with me every single day I will come to you. Uh, this is the discovery of the John Evershed. It is there in our observatory, and this is a spectrum he used there in Kodaikanal, and there is a spectrometer he used. And olden days, they used to take in a glass plate. He discovered there is a flow of gases around the penumbra of the sunspot, and this is a 6-inch telescope, and every single day from that year 1902 till date, they are taking the data. And you may ask me, what is the use of that one? Am I right? I will tell you at the end of the story. Is it okay, or you want me to tell now itself? இப்பே சொல்லணுமா அப்புறம் சொல்லட்டுமா? Okay, I will tell you at the end of the story, I will tell you. So, and we can develop all the stuff, and we can make the photograph. And now, with the help of the digitizer, we have digitized all the olden plates. We can do the measurements of the sunspot, all the things using the grids kind of the stuff. And every 7 degrees, the sun will be tilting, and that can be made as in the chart. So we call it a degree chart. It is there in our degree chart. We have old instruments, like we can duplicate all the old photographs, and we can zoom it, and we can also develop it, and the photography stuff. Now I would like to show you here, you are seeing about the instrument. Okay, let me skip it. This instrument can multiply it, or you can particular region of the photograph, you can zoom it. And this is a film holder. You just take the old photographs, and you wanted to zoom it, and you want to show it, then you can see all the old instrument here. Then this instrument will be used to take the photograph, and one side another thing you can dim and dip, meaning nowadays the digital facilities has arrived. So you take one picture, and you take after some time you take another picture. You can subtract one from another. Nowadays, because it is digitally, it is possible. When you are subtracting one image from other, any movement you can see it. Any object which is moving, say for example a comet is moving, and one photograph it will be there in one position, and the next photograph it would have changed the position. So there will be a gap will be there that will look like a dark patches, and a new position it will be showing in a white one. So digitally it is possible, but in the olden days what they have done, they used to this kind of the instrument. It is a Chellasamy instrument. Now we are not using this old instrument, because digitally techniques have come, and the old 4-inch telescope, and we can also take like a doctors, they used to take see that all the stuff, you know. This instrument is called a heliograph, and till the year 2014 they regularly used to see the outer layer of the sun. With a 6 centimeter image, they have recorded for a longer time. And they have observed at the calcium K, which is a wavelength of 3933, as well as the hydrogen alpha 6562.8, that particular wavelength. They used to study with different filters, they used to take the images here. And it is in a very good working condition. Only thing, we don't have the photograph for that. Like the olden days photograph is not available. Okay. So the primary mirror, it's a front silvered or front coated mirror. It is still there. And I don't know the year when they brought it here to India, but I believe it is one of the oldest instrument, maybe 1900 or so, because they have taken some of the images. It looked like it is till the year 1975. University of Cambridge, they were using the similar kind of the setup. They call a siderostat that will reflect the mirror or image of the sun to the back end observatory, okay, laboratory. And the optical setup within that one you can see. This still you can see this spectro building. And old time, nighttime observations, we are planning to do that one, which is called a DFM telescope. We are going to mount in this one. And I just wanted to tell you about John Dahlmeier. Dahlmeier, he is a German basically, but he came to England and he built almost 5 or 6 telescopes he made. All the telescopes are spectral based telescope he made. And still it is there with us. In Kodaikanal we have it. And astronomically it is not very much useful, but it has produced a lot of old results. Okay, he is John Dahlmeier, and you can also see his credibility in the website. You can see about him. One of the working clock may be very, very old, starting from the time of Captain Cook. This clock, they made some 5 or 6 clocks. One is I heard that is in Australia. One is with us. Even now it is in a good working condition. And it is a very unique clock. It has the pendulum, and the rod will be made up of multiple metals, because when you put in a multiple metals, the expansion will be controlled. The coefficient of linear expansion will be controlled with a pendulum. If you use the multiple elements, then the expansion will be uniform, and it is put in a container so that the variation will be very less. The change in the length because of the temperature will change your period. Am I right? When length changes, period changes. When period changes, time changes. You are absolutely right. I am looking for some gifts for you. At the end, you can collect from me. Okay. And the coefficient of linear expansion will be arrested by the multiple methods, multiple layers of multiple metals. They are arrested. This is a very good thing. And Professor Kochar, he wrote an article about this clock. This is one of the oldest clock, maybe I think it may be in India, working clock. And we have many other clocks also there in our laboratory. And let me quickly take you to the new instruments. And vernier calipers, you all know that one, like a least count and all the stuff. That can also be measured with this kind of instrument. It will go to the back end, and a lot of worm gears and all the stuff is there. Very interestingly, this instrument is in a good condition. Only thing, we don't have the photograph or thing. And the back end, we have another instrument we call the grating. How many of you heard about the word grating? It's a very easy question, 2d sin theta equal to n lambda, am I right? If n is, they will give lambda, they will ask you to find out the order and all the stuff. It's a very practical question. So grating is there. Within 1 millimeter, you can put that is 1,000th of the lines. But the grating what we have, it's much more superior than that. Okay. And comet Halley is observed with Kodaikanal in the year 1910. And the same comet repeated in the 1986. It is all the data, documents, all the things are with us. Here is the tunnel telescope, and it's one of the biggest telescope in Kodaikanal, the 62 centimeter big mirror with a 3-mirror system. And we have at the end, we have the grating. And in 1960, it was look like that. And you are seeing, you remember I was telling about a 3-mirror system. This is one of the biggest telescope. In the year 2019, I think 2019, December, you came for that one along with Professor Pasakap. Oh, you came. And we took a picture there. This is an annular solar eclipse that appeared only on that particular day. And prior to the day, it was so cloudy. The next day also so cloudy. The sky was only clear, particularly for on that particular day, it was very much clear. At the back end, we can see the grating. You remember I was telling about a calcium K profile. And remember I was telling about Wilson-Bappu effect. I hope you remember about Bappu. Bappu, he discovered in the year 1957, the width of the calcium line is changing from all the stars that he discovered here. And every single day for the past 30 years, at a different latitude, we do the scanning. And that will tell about the study, or we are studying in detail about the sun. And we are studying the most abundant gas in the sun atmosphere is hydrogen. You are right, correct. Hydrogen is the most abundant gas, and the wavelength corresponding to that one, that transition, we call it the Lyman-Balmer bracket series fund. You must be remembering that particular Balmer series that you can see. The telescope is operating at the wavelength of 6562.8. Very interestingly, the man who is operating the telescope has come over here. He is also an American college student. Is it surprising for you? Can I request him to stand up? Can you please introduce yourself? Yeah, I'm Prabhu. Okay. See the audience. Such a, okay. I'm Prabhu. I'm 06 KGB 28. Yeah, Thank you so much, Prabhu, for coming all the way from Kodaikanal to witness our friends here. He is every single day, rain or shine, he will be there in the office, and he is operating this telescope. And the bigger tube you are seeing is a science tube. Another one is a collimating tube, or it will be adjusting. And earlier days, we used to take 2 or 3 images, but nowadays Prabhu is taking tons of images. And he used to take and he used to do the calibration. and put it on our website. You are seeing here, and let me take you to another one. Okay, this is the images he used to put every single day on the website. He do the calibration. You can, on the, if you are seeing the outer layer of the sun, if you are seeing a coronal loop or something, it will look like a very outer layer you can see. But on the cooler region, on the disk side, if it comes, it will look like a thread kind of the stuff. We call coronal, you are seeing a lot of coronal features there. And everything is, we can study in detail. We can measure the width and oscillations and all the stuff, we can measure it. If you need further discussion, you can contact Prabhu. And we have another telescope called, this is sort of the modern telescope. We call it a white light active region monitor telescope. And front side, it will be, all the time it will be rotating in the same rotation speed of the Earth, so that the image will be stationary. Let me take you to the back end. We have the optical table, and the beam splitter is there. One beam, it sends to the white light images, otherwise we call the continuum G-band images. The other one, we take calcium K. 3933, we can take that image. That also, it is being uploaded in our website every single day. All the old data, whether it will be useful or not useful, it's a treasure. How do you use it? You just do the digitization. You just, all the old images, we take the images. He is a friend of, he is for five generation, he is working in our observatory. His father, forefather, and forefathers. And his name is Satish, and they used to do the digitization, all the pole marking and everything they do, and this image is all uploaded in our website. Okay, it's meticulously kept from the year 1902. It's really a treasure for our observatory. And somebody asked, what is the use of all the observations? Am I right? One can study about the long-term variations. See, sun, what you are seeing is not the sun, what you are seeing the next day. Okay, sun keep changing because the core of the sun is rotating very fast compared to the polar region. Therefore, the field lines, whatever you are thinking, it's more like it will be twisted. When the field lines are twisted, what it will happen? How long one can twist it? How long one can twist? There's a limit for twisting, am I like? How, it's more like how long I can irritate you. One fine day you will bounce on me back, okay? I can ask 1 or 2 questions. If I keep on asking questions to you, you will get bugged up, am I right? Similar way, the field lines cannot be twisted for a longer time. What it will do, after millions of years, the field lines will break open. When the field lines, I am just telling illustration, don't think that sun somebody is twisting, okay? Core of the sun is rotating very fast because we all know the differential rotation of the sun. And the sudden release of the material, like the stored up energy, will be suddenly released. Million megaton materials will be thrown out in the space, interplanetary space. That will go at the speed of more than 1,200 to 1,500 or even 2,000 kilometers per second. Are you with me? 2,000 kilometers per second. You are sitting in a bike, somebody drives you at the speed of 200 kilometers, what you will say that? Ayyo, pochuda. If somebody is driving at 300 kilometers, you are sitting at the back, means you just imagine. I am telling not hour per second. When the speed of the materials, the coronal mass ejection goes from the sun, you can, all the things you can study from Kodaikanal. It's not very far away, just 4 hours from you. So please visit. And this coronal mass ejection produces a shock. That shock produces a wave called Langmuir wave. The Langmuir wave is an unstable wave. Its decay into electromagnetic wave can be detected from Kodaikanal. Okay. So somebody asked me, what is the use of all your studies? We studied about the sunspot at different sizes. The different sizes migrate from the polar region to the equator and look like a butterfly. Am I right? It looks like a butterfly. This is one of the longest duration. Let me repeat, this is one of the longest duration or studies of ever human mankind did on the planet Earth. All the science data are secondary. This data is one of the longest data on the planet Earth. Okay, and we can study about how the behavior of the sun at every 11.2 years, the sunspots will grow higher, then it will go deep, then again go higher, and then go deep. That is being studied at Kodaikanal. And so many people around the world, they are using our data, including Prabhu and me. Okay, and we publish all these things in leading journals. And of course, I need to tell you a few words about radio astronomy. Very recently, we have installed a radio telescope. Sun is also a good radio emitter, and radio emission from the sun can be seen or recorded with a radio spectrograph. This telescope is there in Kodaikanal, and at the back end we have a Pumban well. We used to say 8 elements of same telescope we have installed. You can also take the data. It is there in our website, and we have put a polarimeter also, and we, every single day, starting from 35 megahertz to 435 megahertz. In the sun atmosphere, approximately 1.2 solar radii up to region of the 3 solar radii. Almost 3 million kilometers one can measure with this telescope. Okay, very interesting, and the sun is entering into the beam and exiting at the 40 megahertz, and we have a very beautiful library. Can anyone can tell who is he? Not old professors. Professors? Nobody knows? Okay. Somebody? Professor Seduraman from our Americancollege. He visited along with his grandchild. He stayed for a week here in our observatory, and he gave the lectures and all the stuff. And he taught optics and Fourier optics he taught for us. And we have a good, beautiful library, and we have a lot of guest houses and museum. This is one of the oldest transit telescope room, and we have put a Canon like a transit telescope we have at Kodaikanal. We conduct schools. It's very interesting. Like you can apply all over India, almost 800 students apply, and we select almost 40 students for our thing. Most of them are gold medalists from the universities. Almost 200 university students, gold medalists will apply. We give a special preference for Americancollege students. Please do come, please do apply, and it will be very interesting. It is a very interesting career. Future, we just wanted to change our speed to, or our observation to adaptive optics. We are in the pipeline, and we can improve the signals and all the stuff. This is my Kodaikanal staff, including Prabhu, and thank you so much. Thank you. I told about the old stuff, and I told about Kodaikanal recent observations. You are most welcome to visit Kodaikanal Observatory. You can stay there, and you can do studies, and you can analyze our data and all the stuff. Thank you so much. Over to Madam. If students have any questions, they can raise up the hands, and I would like to answer. Language doesn't matter. தமிழில் கேள்வி கேட்கலாம். எனக்கு நல்லா தமிழ் தெரியும். தமிழ்லேயே உங்களுக்கு பதில் சொல்கிறேன். I appreciate your patience as well as your time. Okay. Students? Some intelligent students, they can ask questions. Okay, non-intelligent students also ask questions. No questions. Either you will be there intelligent or, okay. Some students are there interested. Oh, very good. I appreciate your patience, appreciate your, okay.
Being observing the sunspot from this much long duration, how far you are achieving something or finding something new in this sunspot?
What we have found new in the sunspot, like yes. The sunspots, they form and they grow bigger. When loses its energy, they started shrinking, and in the face of the photosphere, we can see the sunspots, and sunspot will disappear after some time. So the sun is also rotating. I think most of you may be knowing that, like Earth, the sun is also rotating. How long it takes a sun to rotate one full circle? Anybody? Some answer? Can we ask the question to Prabhu? 28. It is not a gift to Prabhu. Okay, the one who asked that one. 28 days sun will be rotating. As the rotation happens, like we can see after one rotation also, like 14 days we can see on the visible photosphere of the sun. After that it will go to the backside because of the rotation we cannot see. Nowadays we have some more telescopes are there to see from the backside of the sun, and we can track of that sunspot. It will come back, emerge back. So the sunspots will, as it is rotating, they will give rise to a lot of flare activities, like whenever the reconnection happens or some kind of the North Pole or South Pole touch each other, then they give a flare kind of the stuff. That can be seen in the radio wavelengths or gamma ray and ultraviolet, on multiple wavelengths we can see that one. From starting from gamma ray to radio, we can see the signatures of the radio flares. These are very much interesting to study about sunspots. Thank you. I don't have any more gift to give. So, okay. Thank you. I will give it to Madam. KG sir.
சார் பல்சார்ஸோட அவ்வளோ வெயிட் காரணம் வந்து அதோட ஸ்பேஸ் டைம் கர்வேச்சர்ஸில் வந்து அவ்வளோ பெண்ட் அதிகமாக இருக்கிறதுனால சார் அது அவ்வளோ வெயிட்டாக இருக்குது.
Depending upon pulsar is so massive because of the matter. It is not the curvature and all the stuff. Pulsars is the remnants after the supernova remnant. Like you all might be knowing about the stellar evolution. Like when iron 54 happens, like the shell, outer shell will be very, very strong. There it won't allow any more further expansion of a star. Star is balanced by the two things. One is the internal gravity. The gravity is pulls down and the radiation is making them to expand. And they strike a balance between these two things. That is, we study as a one semester course on this one, like a stellar evolution. And when iron 54, when it forms, then it won't allow the radiation to further escape. So internal temperature increases. One fine day it will break open, and that we call as a supernova remnant. When supernova remnant happens, that remaining materials will form as a neutron star. A neutron star, as I already told you, the scope of neutron star material will be so massive, and that will be rotating. That's what Professor Radhakrishnan and along with Cook, and in the year 1969 they discovered there is it is curvature radiation is happening. It's more like a lighthouse model. Like a lighthouse, whenever beam comes towards you, you'll be seeing. Otherwise, you are not seeing anything. Similar way, the pulsar, it has the rotation and it is also having the beaming effect. That lot of calculation have been done, like its light cylinder and the rays of which is can expand and all the stuff. It's stellar evolution and the star forming stuff. We'll be having the another class here in the same place in the March 18th maybe. You can ask many questions about neutron star as well as about the black hole and everything. Professor Arun Mangalam is giving a lecture in the same hall in the month of March.
சார் இப்போ நம்ம அதுக்கிட்ட ட்ராவல் ஆகும்போது நம்மளை காப்பாற்றிக்கிறதுக்கு ஒரே ஒரு வழி என்னன்னா, நம்ம ஆர்டிஃபிஷியலாக வந்து நம்ம ஸ்பேஸ் டைம் அந்த பெண்டை நம்ம ஒரு மிஷினை ஜென்ரேட் பண்ணாச்சுன்னா நம்ம நியூட்ரான் ஸ்டார் பக்கத்து போனாலும் நாம் சர்வைவ் ஆக முடியும். அப்பேற்பட்ட ஒரு கிராஃப்ட் இருந்துச்சுன்னா நம்ம இன்டர் டைமென்ஷனல் அந்த ட்ராவல் வந்து நிச்சயம் பாசிபிள் ஆகும் சார், வித் லோ எனர்ஜியோட.
எனக்கு தலை சுத்துது நீ பேசுறது கேட்கும்போது. Okay, let me not give any comment to you. Like even to go to Mars, we have so much of difficulty.
No sir,
and
நான் சொல்றேன்
telling about Pluto, the Voyager which started in the September 15th of 1977. Now only at the speed of 40,000 kilometers, the speed in which it is going. Now only it is entered into the interplanetary space or Pluto. In the light speed, if you are telling, only 500 minutes it has moved. You are telling about a pulsar which is 8,000 light years away from you. I don't know whether you are with me.
சார் இல்லை சார், நான் சொல்ல கிளாசிக்கலாக சொல்ல சார். நான் வந்து இன்டர் டிமென்ஷனலுக்கு வந்து நம்ம ஒரு ஸ்பேஸ் டைம் வார்டெக்ஸ்குள்ளே நம்ம மாட்டி மறுபடியும் இன்னொரு இடத்துல நம்ம வெளியேறுவோம் சார். அப்படி போகும்போது வந்து லைட் அதுக்கு வந்து ஒரு மேட்டர் இல்லை சார் அந்த ஸ்பீடில் போகிறதுக்கு.
ஆமாம், நீ நல்ல ஆமாம், இது வந்து நல்ல
பாசிபிள் இருக்குது சார்.
ஆமாம், வார்ம் ஹோல் இதெல்லாம் நானும் கதையில் படிச்சிருக்கேன்.
நியூக்ளியர் கொலிஷன் இன்ஜின் மூலமாக அது பாசிபிள் தான் சார்.
நம்ம ரெண்டு பேரும் தனியாக பேசுவோம், எல்லாருமே நிறைய பேர் சிரிப்பாங்கன்னு நினைக்கிறேன். நம்ம முடிச்ச பிறகு நம்ம பேசுவோம். ரொம்ப வெரி இன்ட்ரெஸ்டிங். Okay, now it is I think over to Professor KG. After that he will announce for the tea time.
Thank you, sir.
Dr. K. Gnanasekhar will deliver vote of thanks.
Thank you, sir. for your inspirational and motivational talk. You have made the whole session very lively, and this is something knowing about how the various instrumentation that you try, that you have the hands-on experience in the laboratory is transformed to reality, and knowing about the space and understanding the various solar entities and its influences on the human being. We are all came back from pandemic. Okay, we all think that virus is a very coronavirus. It gives a threat to the human being. It gives a threat. Actually, it gives an opportunity. Coronavirus gives an opportunity to the human being in the world, not the threat. Because as a student, others, our colleagues knowing about it, human system, biological system has learned many things only from the virus. Do you know that? Human biological system has learned many things only from the various kinds of virus. Not only the coronavirus, today we know about it. There are many kinds of virus. Actually, if you look back the history, once in 100 years, there is one kind of virus. It gives threat to the human. But that's not a threat actually. It's an opportunity. Just to say, as an example, the human system known about the memory. Without memory, we can't think of today any human system. So which is one thing which is very special. The memory is only learned from the virus. Initially, human system don't know about a memory, the idea of memory. It is learned only through a virus. Okay. Similarly, it gives that's why I'm saying there is an opportunity to the human being to learn. Okay. So, as a scientist, as a physicist, as a biologist, we should take everything. It all comes from, because we are all not the whole universe. We are only a speck of the universe. Is it not? Only a speck, very small dust of the universe, single dust of the universe. The whole solar system, if you look at the whole universe, the whole solar system is itself a dust. Okay. So this is a very special facility that we have, and still working almost for more than 150 years. I think it's from 1900, even before 1900 it has been. Many great scientists have established it, and it is a great treasure that if you look at that tunnel and walking through the telescope, imagine, it's not using the telescope. If we go there and we can walk through the telescope and see the solar image, that is a special telescope that we have, and we are very proud to have one of our alumnus as the present director of the Solar Observatory, and we expect you all contribute to the humankind through taking up all these challenging. There are plenty of challenging task is there in the present day. Not only the hybrid computer, now the future is on quantum computer. The quantum computer is all in your hand. You are going to develop it and use it, and we can see and we can reach later, more horizon, cross the universe and know about it. So this talk might open up and ignite the young mind by such an inspirational and motivational talk. I hope many of you will become great space scientists or astronomers and make a lot of contribution to the humankind for the upliftment of the whole society. With this, I take this opportunity to thank especially our chief guest for today's session, and other my dear colleagues, and none other than our students for your patient and participative learning and participative discussion and all that. Thank you very much. Now tea is arranged here. All of you have tea and go back. Yeah, this way. Tea is arranged this side. Go there and have the tea and disperse. Thank you very much.